All right. So I wanted to step away from our kind of learning of new material, and we're going to have our first coding challenge. A coding challenge you can think of more like a quiz, right? Here is our opportunity to test kind of the things we've talked about so far and to see what you remember, what you're still struggling with, formative assessment, if you will. So I want to talk about a few items first, and then I'm going to turn it over to you to solve the coding challenge. The first items I want to talk about are operators. By the way, to do this coding challenge, go ahead and set up a new HTML page. Link a new JavaScript. Do all the setup. It's good to practice, right? We'll call this coding challenge 1. We're not going to link any. We're not going to style this at all. Don't worry about that. But let's do link a script, and that script should be another new file, new JavaScript file. Okay, just get all that set up and linked. That'll be good practice. But that's not really the challenge. So let me start by talking about operators. Operators are things like addition or plus, minus, right? You might do times. You might do divide, right? And we've seen a lot of these before. We've used a lot of them before. If you've done any work in another programming language, you've used them before. These are what we call operators, right? They are used to make changes to variables, types, objects in our programming. We can use the addition sign to do something like console.log 4 plus 7, right? We can run this and we can get 11 out, right? That's an operator. Another operator we haven't seen yet that I wanted to talk about is this operator, modulus. Now, modulus is kind of an interesting operator. Let me show you the result of doing a modulus, and then you can tell me what you think modulus does. So if I do 9 modulus 3 and I log that result, we get 0. Okay, so 9 modulus 3, we get 0. What if we do 10 modulus 3? What do we get? 1. What if we do 11 modulus 3? What do we get? 2. What if we do 12 modulus 3? Back to 0. Interesting. Let's try 10 modulus 2. See what that does. 0. What if we do 4 modulus 2? 0. But what if we do 5 modulus 2? 1. So hopefully you're starting to see the pattern here. If I jump to 6 modulus 2, see if you can guess at what you think is going to happen here. We get 0 again. Okay. So what does modulus do? Modulus. I spelled it wrong. Oh, maybe I didn't. Modulus. Let's look at modulus JavaScript. Okay. Yeah, you can see it right off the top, right? Remainder. Modulus gives you essentially what would the remainder be if we did this division. And if we run these, you can see 13 divided by 5, the remainder would be 3. Negative 13 divided by 5, the remainder would be negative 3. 4 divided by 2, the remainder would be 0. Negative 0, okay. But you get the idea, right? That when you do modulus, it's essentially telling you what the remainder would be after division. Okay. So that was one thing I wanted to talk to you about, was this modulus operator. So I also wanted to remind ourselves of sort of control flow. Okay. So let's say we wanted to write a program that was going to test how many times one number went into another number, right? So if I said let num1 equal 15, let num2 equal 5, if num1 divided by num2, and now let's see. Oh, I have to actually write it. If num1 divided by num2 equal, right? We use our equal for comparison. If I wanted to know that, well, let's say, first of all, I wanted to know whether or not num1 divided by num2 went in once. I could say 1. That would be fine. But if this is, let's say, 6, this isn't going to work. This isn't going to work because while num2 goes into num1 once, right, there's a little bit of a remainder. So we actually, in this case, maybe want to use like less than or equal to, right? So if num1 divided by 2 is less than or equal to 1, maybe. Well, no, not that. So we want maybe greater than or equal to 1. Okay, well, maybe. Now, I want to know, well, what happens in this case now if I do 15? So let's say we did 15. We do console.log, and we say number, or we can just actually, we can use, let's use string interpolation. That'll be clearer. Num2 goes into num1 at least, or once. We can say once. That's fine. I made a mistake here. Right, I need my dollar signs. That's why we're not getting the correct formatting color there and there. All right, let's run this and see if this is going to work for us. Come over here. 5 goes into 15 at once. 5 goes into 15. We just need once, right? 5 goes into 15 once. Oh, that's not right. Well, what if this was 6 again? Would that be right? Okay, that's right. So what about the issue of 15? Well, let's do an else if, right? Else if, and we can take this code, kind of reuse it, right? Copy, Command V. Maybe we want to do 2 here. And we can copy this and just change once to twice. Run our code. Okay, that works great. 5 goes into 6 once. That's true. 5 goes into 10, though, twice. Wait, what? 5 doesn't go into 10 once. Okay, so what's our problem here? Let's think through our logic. We do this math, and we find out, wait, 5 does go into 10 kind of more than 1, right? More than or equal to 1. Oh, that's not great. So this gets caught right away before we ever get to this test. We might think, well, you could do equals equals, right? But we remember the problem with this is, if this is 6, then it's going to say nothing, right? It's not going to catch it here because it's not equal to 1. It's also not greater than or equal to 2, so it's not caught there. So actually what we have here is probably an issue of order. We're testing kind of our most inclusive first, as opposed to testing our most exclusive first. So that's what we want to do probably, is test our most exclusive first. So we could say, what if this is, and let's say we were only ever going to go up to 3. And then we copied this, Command copy, Command V. We could make this 1. Okay. Now let's see how this works. Now we've got something that works a lot better. 5 goes into 6 once. Sure does. 5 goes into 12 twice. Great. 5 goes into 17 3 times. And then if we really wanted to, we could just do an else to catch everything else and say console.log copy. And we could just say something like a bunch, right? So if this was 300, it would skip all the other ones. It would say 5 goes into 300 a bunch. Oh, wait, 5 goes into 300 3 times. I made a mistake here. Because our least restrictive is actually up here, our most restrictive is up here, but it still includes all numbers that are greater than 3, we have a problem. So our else doesn't actually catch it because this triggers here. So the question becomes, well, how might we limit it so that it doesn't go over 4? The way to do that is to use ampersand, 2 of them. We can say ampersand twice, and then we repeat essentially most of this phrase at least. We're at least going to do the division again, but this time we're going to say we also want to make sure that this is less than 4. Uh-oh. We got caught here. Now we are not getting triggered here because while we are greater than or equal to 3, we are not less than or equal to 4, so we're not getting caught here. So we're getting caught here. Okay, well, we can add this on here now. And instead of being less than 4, we need to be less than 3. Same problem, right? Except less than 3, we need to be less than 2 here. And now we have a working, if naive and simplistic, a working sort of test, right? And I show you all this just as an introduction to your coding challenge, right? This is relatively simplistic. Here's your coding challenge. It's a classic coding problem, and if you've had fundamentals before, you've probably already done this problem, but it'll be good for you to practice doing it in JavaScript as opposed to Python. So here we go. The name of this problem is FizzBuzz. And here's what you need to do. Given a number, so you want to prompt the user for a number. And some things to remember about that. We want to remember how to prompt the user. We want to remember what type of information a prompt is sending back to us and how do we convert that type into something we can use mathematically, right? Some things to think about. So we're going to prompt the user for a number. We're then going to test that number just like we were testing that previous number using if-then control flow kind of stuff to see if the number is divisible by 3, 5, or both. Okay. We want to see if that number is divisible by 3, 5, or both. And by the way, what do we mean by divisible? Remember our conversation about modulus, right? We know something is divisible if modulus equals 0. If the modulus of something equals 0, we know it's divisible. An example might be 10 modulus 5 equals 0. Therefore, 10 is divisible by 5. Okay, that's an example of what we're talking about. So you're going to test that number. We were testing to see how many times the number went into another number. You're going to test to see if the number is divisible. And then, if the number is divisible by 3, console log to the console fizz if the number is divisible by 5, log to the console buzz. And finally, if the number is divisible by 3 and 5, example 15, right? Log to the console FizzBuzz. There are a couple of different ways of structuring this. You want to try to keep this as efficient as possible. Like we just did with the code we were practicing with, you're going to have to run it and test it and run it and test it and try a bunch of different numbers, right? You want to test as many numbers as you can think of and as many situations as you can think of to try to get this to work. A number that's not divisible by either, a number that's only divisible by 3, a number that's only divisible by 5, a number that's divisible by both, 3 itself, 5 itself. These are all cases you're going to want to probably test on this code, okay? Assuming you can get working code, that'll be full credit, that does all of these things. If you get code that at least prints fizz and or buzz when it's divisible by 3 and or 5, that'll be partial credit. Obviously, if you can't get any code working, there's not going to be any credit for that. All right, good luck.